For today's lesson, we will be discussing about trigonometric ratios. So trigonometric ratios are used to express relationship between angles and sides of a right triangle. So there are 6 trigonometric ratios in total, and we will discuss them one by one. So for all triangles ABC with acute angle A, so let's say we have this right triangle here. Then let's label it as A, B, C. Now the opposite sides of each angle, we label this as A, this one as C, and then this one as B. So let's use this triangle to discuss the trigonometric ratios. So let's just use this angle A. So first is we have sine. So to get the sine of an acute angle, so we will be getting the length of the opposite leg divided by the length of the hypotenuse. So with referring to angle A, so the opposite leg of this is A. Opposite leg means the leg opposite the given angle. So that is A over the hypotenuse, which is C. So again, remember, sine is opposite over hypotenuse. So that's right here, opposite over hypotenuse. Or to easily remember it, we can use sine, then it's opposite over hypotenuse. Next is we have cosine. To get the cosine of angle A, so we will get the length of the adjacent leg and divide it by the length of the hypotenuse. So looking at angle A, the leg adjacent to it is B. So we have here B divided by the hypotenuse, which is side C. So it's adjacent leg over hypotenuse, or B over C. So let's write here adjacent over the hypotenuse. Or we can write it as C then AH. So cosine adjacent over hypotenuse. And third is we have the tangent. So to get the tangent of A, so it's now the length of the opposite leg over length of the adjacent leg. So again, looking at angle A, the opposite leg of it is side A, and then the adjacent leg is B. So we have here A over B. So tangent is opposite over adjacent. So this can be written as T and then OA. So you can actually use this shortcuts right here to easily remember it. So in short, we have katowa. So this will give us a hint on the ratios between the sides. So for the sine, it's opposite over hypotenuse. For the cosine, it's adjacent over hypotenuse. And for the tangent, it's opposite over adjacent. Next is we have cosecant. So for the cosecant of angle A, or any acute angle, we will get the length of hypotenuse divided by the length of the opposite leg. So looking at angle A, the hypotenuse is side C. So we have here C. And then the opposite leg is this one. So A. So it's C over A. So again, it's hypotenuse over the opposite, or cosecant hypotenuse over opposite. Next is we have secant. So if you're getting the secant of any acute angle, so just divide the length of the hypotenuse by the length of the adjacent leg. So the hypotenuse in this triangle is we have C, and then the adjacent leg is B. So hypotenuse over adjacent. So for the secant, hypotenuse over adjacent. And then last is we have cotangent. So cotangent of A, so you will get this by dividing the length of adjacent leg by the length of the opposite leg. or in this figure, we have B over A. So adjacent over opposite. Or we can write this as cotangent adjacent over opposite. So as you can notice, these three ratios right here, the three trigonometric ratios here, are just the opposite of the first three. So for cosecant, it's the opposite of sine. For secant, it's the opposite of cosine. For the cotangent, it's the opposite of tangent. So for you to remember the last three trigonometric ratios, we can use the cho, sha, cow. So cosecant, it's the hypotenuse over opposite. Secant, hypotenuse over adjacent. Cotangent, adjacent over opposite. So now let's solve for the trigonometric ratios of the given angle theta here, given the length of each side of the triangle CAN. So we have to remember again the pattern so that we can easily understand. We have the sokatowa, and we also have the cho, sha, cow. Okay, let's start with sine of the given theta. So to get the sine of this given angle, we have to get the opposite side or the opposite leg and the hypotenuse. So the opposite of this angle theta is this one, which is the side CA, and that is 4. And the hypotenuse is 5, which is the side CN. So you have to simplify this if you can still simplify, but if not, then this will be our final answer. So sine of the given theta is 4 over 5. Next, for the cosine of theta. So we know to get the cosine, it's the adjacent over the hypotenuse. So the adjacent of the angle theta is side AN, which is 3. And the hypotenuse again is 5. So it's 3/5. Now let's get the tangent. So for the tangent of theta, we can get this by dividing the opposite side by the adjacent side. So again, the opposite side is 4 and the adjacent side is 3. So it's 4/3. Next, let's solve for the cosecant of the given theta. So to solve this, we'll just get the hypotenuse divided by the opposite. So the hypotenuse is 5 divided by the opposite, which is 4. So as you can see, it's just the opposite of the sine. Next, we will get the secant of the given theta. So it's the hypotenuse over adjacent. So it's 5 over 3. Again, it's the opposite of the cosine. So last one, let's get the cotangent. So cotangent of theta is adjacent over opposite. So it's 3 over 4.